Hi everybody, this is Miss Shannon. I'm going to be filling in for Mr. Paul today for today's STEM activity, and we are on a physics unit. So today I want to talk about mass and weight distribution. And with that, I think it's important to discover what shapes hold up weight. And you might be thinking, shapes and weight, what does that really have to do with anything? But I want you to stop and take a minute and look around your house. What shapes do you see in your house? What shapes are your walls? What shapes are the windows? Have you ever been in a cathedral and seen the arched openings? Or maybe you've been in a tunnel and noticed it's kind of curved and round. There's a reason for that. There's a reason why we choose different shapes for different weights. And we're going to discover that today. So you can see I have 3 sheets of paper here. They are 6 inches by 9 inches, and it's just regular construction paper. So go ahead and choose your paper, and it doesn't really need to be much larger than this. I find that 6 by 9 is a really good size for this, and again, just plain old construction paper. If you don't have construction paper, you can use computer paper or whatever you have in your house. But you want something with a little bit of flex, not hard like cardboard or chipboard, but also not super flimsy like a paper towel. I also have a bunch of tape. Now, I only have packing tape in my house. I think that my regular Scotch tape is probably packed away with Christmas stuff. So there we go. Packing tape it is for me. And I already cut myself some strips. And then I have a ton of books because that's what we're going to use to see how much weight that these shapes can handle. So the first shape I want you to do is something round like a tube. So go ahead, fold yourself a nice tube. Make sure it overlaps quite a bit because we want to make sure that it at least has a good surface area to tape. And then go ahead and tape that tube closed. Okay, I have my paper tube all taped up, and you can see it is freestanding just fine. The next shape is going to be a triangle. Now this is what's kind of important. Keep that paper tube circle that you just made handy because you want your triangle to be about the same size. So first I'm going to kind of make sure they're about the same size, and then I'm going to work on folding my edges down to make it a triangle. So you know a triangle has 3 sides. It's okay if they're not perfectly even because we will figure that out as we go. You will need a little flap upon which to tape it. So you can see I have about an isosceles triangle here, a triangle that has 2 equal edges. If you are really fancy, you might be able to make an equilateral triangle. An equilateral triangle has 3 sides that are all the same length, but I chose isosceles. So again, go ahead and tape that down. You can see the triangle's a little bit bigger, but not too much. So these are around the same side. And again, I have nice firm creases. So the last shape we're going to do is a square or a rectangle. So 4 sides, you're going to need 4 strips plus that little flap. So it might be helpful to fold your my book's made a run for it. It might be helpful to fold your flap first and then work on your 4 sides. Pretty good, right? Nice squarish shape. Use your tape, fold that flap down so it's nice and sturdy. Okay, so I have my circle, I have my triangle, and I have my square tube. So right now, make your hypothesis. What shape do you think is going to hold the most weight? Again, maybe look around your house, wherever you are right now, and see what is holding up the weight of your house. What shape is that? And maybe that can help you make a hypothesis. Or think about structures that you've seen. Think about bridges, think about tunnels, think about cathedrals or archways. Think about any place that you've seen that's holding up quite a bit of weight, okay? Maybe even think about your own body. What shape are your legs? Your legs hold up a lot of weight, okay? So we are going to start, triangle's my favorite, so I'm gonna start with the triangle. So I'm gonna start with a chapter book. I'm gonna put my chapter book on there. There's 1, and it's holding. 2, you might want to stagger them so they don't all topple over. 3, oh, 3! I don't know if you saw, but this edge right here, it crumpled, it buckled right in. This can only handle 3 chapter books. That's not pretty good for the triangle. All right, let's see. Let's go to the square. So these were the 3 books I used with the triangle. Here's 1, 2, 3. Okay, the square is doing a lot better. This is already 3. 4. 5. Ooh. Move that over a little bit. 6. Wow, the square's doing really well. 7. 8. Ooh, it's starting to make some crinkly noises. I hope it's all right. 9. Oh, wow, we went through all. Oh, 9. 9. I was getting excited. I thought that we went through all of our chapter books and we could start moving on to these smaller books. But no, look, it crumpled right here in the center. This fold, probably because it's folded. If this was a solid piece, it might have been okay. But it buckled right there, and you can see this break line. It just crumpled right there at that spot. Huh, interesting. So I think that's an interesting thing to notice too, is with the square, it crumpled mid-tube right here in the middle. But with the triangle, it folded here at the bottom. How funny is that? Okay, so the triangle had 3, the square had 9. All right, guys, let's see about the circle. I'm gonna move all my chapter books to the side here. Here we go, circle. Don't let us down. All right, here's 1, 2. Oh, it's making crinkly sounds already. That's not good. 3, 4, 5, 6. Okay. 7, 8. Guys, this is doing so well. It's so sturdy. 9. Okay, let's try to move these smaller books down. 10. 11. Guys, we're double digits. 12. 12 books. Woo! I'm making a mess. 12 books. Now, this is what's interesting. This held 12 books, but look where it crumpled. At the bottom. And this is a big crumple. This failed also at the bottom. Small crumple took it down. But this only held 3. So I think it's really interesting to think about how weight is distributed. So when you saw me stacking all these books, the weight was pushing down on the tube. Now, this failed first because when the weight comes down the sides of this triangle, it has 3 corners. Corners are not strong, okay? And it pushes the weight out, and it doesn't have a lot of stability here. There's too many angles that can fail. Now the square, you might think, okay, well, too many angles. The square has more angles. So you would think that this would fail fast. But because the strength of the walls, this shape here, it's more even. With the triangle, it's not balanced on all 3 sides. Had I done an equilateral triangle, one with 3 equal lengths on the sides, we may have gotten more weight out of this shape. But because the sides are not equal, they're not sharing the weight the same. But with this square, it was able to distribute the weight of the books evenly and last longer, which is probably why it failed in the middle and not at the bottom. Now, this bad boy, the circle tube, was amazing. I can't believe it held that many books. 12 books, that's crazy. And what does the circle have? It does not have any corners. Well, now it does because it's been crumpled. But initially, it does not have any corners, which means that all of the weight of those books was perfectly evenly distributed through all sides of this. There are very few failure points in this. Again, if this had been a solid piece and not a taped tube, we probably would not have a failure so soon. We would have achieved more strength out of this. But because we have this break point here where I taped it, this is where the failure occurred. So I want you to practice this, come up with other shapes, maybe a star. What about a long skinny rectangle instead of a square? Maybe you want to do a hexagon or an octagon, or test out different ways of folding this. So we attached our tube here, but maybe you want to make your break line on a bias, kind of going down the side like a toilet paper tube. Maybe you want to experiment with different kinds of paper and see, for this experiment, which paper is the strongest. So send me your photos, tell me how it worked for you, how many books your shapes got, and what material you found in your house that was the strongest. Try to stay paper-based because we know wood is a lot stronger than paper. All right, guys, I hope you have a wonderful day, and I will see you later. Bye!